I'd like to tell you about the number 0 and the number 1, and about how, as a human race, we have to be careful what we do with these numbers to solve global warming. So what has 0 and 1 got to do with global warming? Global warming is a problem we know to solve by just reducing industry, dirty industry, reducing pollution, stopping human influence on nature, things like this. Suppose we do all these good things, what is left to heat up the planet? It turns out what is left to heat up the planet are processors, things like the computer you're looking at right now, or the smartphone you're looking at right now, things like this. Or there are chips and processors in all sorts of gadgets. In my case, there's a chip in my bicycle light, but there are chips in fridges, all sorts of things. In fact, soon there will be chips inside the human body, probably inside the brain, in decades to come. They all give off heat. Anytime you add this number to this number, or multiply them, or do operations on them, you give off a tiny amount of heat, which is a principle of physics called the Landau principle, and we can't get around that. And this heat will eventually cause a problem on planet Earth. This heat is equivalent to maybe an ant lifting up its leg while he's walking on the moon. So it's a tiny amount of heat, but it's all going to add up. The way to get around this is through quantum computing. In a quantum computing processor, 0 heat is given off. So it's the ultimate green computing, and it's not going to heat up the planet. What does a quantum computer look like? Well, earlier I took out the processor from my quantum computer, and I just would like to show you the processor itself. So I'll get close to the screen. And if you look carefully at the processor here, okay, I hope you didn't see anything there, because there wasn't actually a processor there. If there was a processor, you still wouldn't have been able to see it, because quantum computing is the ultimate in miniaturization, and the processor would have been not alone microscopic but nanoscopic. In other words, extremely tiny, like trying to look at an atom or at an electron. So quantum computing is the ultimate in miniaturization, as well as being green, which is a second advantage. The third advantage of quantum computing, it can do great things for certain types of problems. Imagine you are a rich king. You've got a palace, 100 rooms in your palace. You've left your book somewhere. You have no idea which room it's in, and you're completely forgetful. How do you find it? Okay, well, there's no better plan than just go through all the rooms in whatever order. You might find it in the first room, but you might be unlucky and find it in the last room. On average, you go through 50 rooms, because there are 100 rooms, so on average 50 you're going to find it. If you more than 50 you're unlucky, less than 50 you're lucky. If you had a quantum computer, you can guarantee to find your book after 10 checks, 10 searches. The quantum computer effectively looks simultaneously in a few rooms at the same time. That's the best analogy that one can say of its operations. So that rich king should head straight down to Curry's and buy himself a quantum computer for maybe $2 million. But yeah, he's a rich king, right? Thank you.